Welcome everyone. This is Dr. Varinder Singh for the course of Engineering Graphics. In this particular lecture, we will be talking about the development of the surfaces of solids. So, it is chapter number 14 in our textbook. So, by the development, you can see typically, so the solid which is a cuboid, so that has been the surfaces of that solid have been shown here. So, they have been put up on a single plane. So, like here you see number of surfaces put up on a single plane. So, here we have developed the lateral surfaces as well as the bases. So, generally we do not develop the bases most of the time, only the rest of the surfaces, the lateral surfaces we develop, that is a practice, but if needed we can develop the bases as well. Now, that has a concern for the manufacturing. Many times the base is separately manufactured, but lateral surfaces are manufactured in a single unit. Okay, so, overall the development is simply laying of the surfaces, different surfaces on a single plane. So, that is what the development is, and these are all true shapes. So, on the development we will see the true shapes of different surfaces. We do not have apparent shapes. So, in a real solid we may have apparent shapes. Those apparent shapes, they are first converted to true shapes and they are put like sewn together. So, that is what the meaning of development. Now, in this lecture we will learn about what principles we have to take care, what guidelines we have to take care when we carry out the development, what is the procedure, etc., and what are the applications very briefly we will talk about. So, we will and in the end also talk about the reverse development. The development, as you can imagine, so it will be useful if you have to manufacture a solid or a shape, a given shape from sheet metal. So, we can cut down that sheet metal on a single plane and then we can give it different bends from different points or different edges, and the shape of the solid can be achieved. So, from sheet metal or from any other sheet, so we can construct the solid. So, that is what the application in reality is. Many times, so we may have certain questions in mind, and those questions can be solved by first putting those surfaces on development. Some examples will be taken towards the end of the lecture. So, to make you understand what is the reverse development, what are its applications. So, we will take up a few simple model solutions and the steps will be clear to you. So, there are other set of videos also available which will make you familiarize with the steps you have to take on AutoCAD. So, you can use those videos also for your learning. Now, the important points you have to keep in mind, they have been highlighted here. So, though I have spoken about them, but you can still understand. So, every line on the development, as I earlier mentioned, every surface is a true shape. So, every line also is a true line, true length. So, on development only true lengths will exist. So, if we have apparent lengths, we first need to convert them into true lengths, then we can transfer them on the development. This point, there is not very big effort which is needed for this purpose. It is not difficult to follow, you will be able to follow it very easily. Then you have the point on only lateral surfaces are generally developed, as I mentioned it in the beginning itself. So, ends we can or bases we can develop, but mostly they are omitted from development, because that is not needed to be manufactured from the same piece of metal. So, that is why the common practice is only the lateral surfaces are focused for development and the bases, they are separately taken care. So, they are not developed because they are anyway mostly true shapes are already known, given, and they can be separately welded on the lateral surfaces after giving the shape. Okay, so, another thing you must note. So, though the cone, cylinders, pyramids, like such regular solids, we can easily carry out the development, but for a sphere and some other solids like toroid, etc. So, we are not able to develop very accurately. So, there are certain limitations on this aspect, but compromising little bit on accuracy, we can still develop the surfaces and we can still cover up those surfaces. So, I already mentioned the usefulness of the development. One thing is, from sheet metal or other sheets you can construct the solid. Another is, so suppose you have a solid, you have to cover it with some other sheet, just to cover, not to only construct, but to cover. So, then also the development is very useful. So, for manufacturing processes particularly which involve sheets, so this development of the surfaces of the solids, that is very important topic. So, from manufacturing point of view, it has tremendous application. So, without this topic, you will not be able to construct the solids from sheet metals, to that extent you can say. Okay, so, now looking into the methods of development. So, we have for prisms and cylinders the parallel line development method, for pyramids and cones the radial line development method. So, we will first focus on the parallel line method for prism and cylinder. So, we will take the case of a cylinder first. You can see on your screen we have a cylinder of height h and the diameter d. Clearly, its circumference, whole of the circumference will be opened, as you can see. So, from this end it is opened here. So, this development from 1 beginning to 1 and going back. So, this whole thing has been developed, though it is not up to scale here, but still I am just saying this is opened from here, and that is what the development is. So, the length of the development will be pi d. So, that is what we have shown here. So, pi d is the circumference and height is h. So, as simple as this. You may ask me why I have drawn these lines in between. Actually, these represent some of the generators of the surface. We all know, so this surface is composed of infinite number of generators. Actually, there are infinite numbers, few of them we have shown. It is not necessarily we show them unless we need them for a purpose. So, here we have shown 12 different generators. So, this is useful when suppose you have certain curve, certain let us say this curvature is there. So, this curvature we want to manufacture a solid with this curvature, which will have in front view a curvature like this. So, in that case what we will do, we will need to transfer these points, okay, so onto the development, and we may be able to see what kind of, so because different points they will be joined together, and I have just put this up only on a rough basis. So, this way, so some profile you can get on the development. So, for or the purpose of the generators is basically when you have to transfer the points. If you do not need to transfer the points, if you just need the development, then you do not need these generators. So, otherwise you need the generators. So, here, so what typically is done, so let us say 12 generators I have marked here, and 12 should be here also. And you must note that the development starts and ends with the same end. So, it is not that from 1 to 12 only you have to develop. You note that if 1 to 12 you develop, then only this much portion will be covered, but you need to cover the whole of it. So, 1 to 1 you have to cover. So, that is something about the development. So, very simple, and if you have to develop the prism, in that case what will be the length? So, in that case let us say you are given the base edge, that base edge is the real length or true length in the top view here. Note that this is the apparent length, this is true length. So, wherever base edge has true length, so that length you can use. So, that much length you can pick up and you can put up here, and then you make so that if it was W, so then so 6 W we have to keep as the length of the development, height will be same as h. So, that is similar to the cylinder. So, that is how you carry out the development for the prism. Other point like we have a curvature here, let us say, so if that curvature is to be transferred, so that curvature, So, you can transfer all the points here, and so finally, you can join them with the P line and then fit a curve into it. So, that may be the procedure, or otherwise if you have only let us say a line here. So, then also something will be then also different points will be transferred and you can get the shape. I will take that in the next problem. So, you can see, but before that we will also cover the fundamental development for the pyramid as well. So, we have a hexagonal pyramid here, let us say. So, this pyramid is having the two opposite base edges parallel to VP. So, you are to, so this is a situation when two opposite base edges are parallel to VP. So, let us say this is the top view and that is the front view, and we are having the first angle projection, and in that case you note that the solid finishes up here itself, and here you note that OD is parallel to xy line in the top view. So, in the front view you have OD, this particular line, as the true length. Okay, so, this particular length is the true length. Why? Because OD is the horizontal line or parallel to xy line. So, this concept you have studied in the projections of lines. So, same concept we are exploiting here. So, once through such concepts we verify that we have a true length here, then that length can be used. So, that is why, so this is part of the development also. So, here part of the development I have shown. So, how do we move further from here? So, what we do, so using this as the radius, using this true length of OA or OD as the radius. So, we can start the development with any of the edge. So, let us say, so if we start with the OA, so then the same point D, so rather than putting it here, so we can also think of just copying this and pasting it somewhere at the same level you can put, because it helps you to transfer the points in case you have the points to be transferred. So, then you can mark an arc, and on that arc you mark the true length of the base edge. So, that true length of the base edge you mark here using an arc or a circle, and then you develop. Okay. So, this way, so first slant surface can be developed, then you can mirror it. If when you mirror it, so it can be done like this, then you can mirror both of them. So, then easily you will be able to get the shapes. So, 1, 2, 3, 4. So, and 2 more you will need. So, that way, so you can carry out, you can complete the development with the 6 different faces. So, I can okay. So, for that matter, just show it like this. So, I have also demonstrated how it is done. So, how it is done on AutoCAD, what different care is to be taken, that is taken care of in a separate video. At the end you will also see a video where physically it will be explained with the help of a model. So, how it has been done. Now, there may be a situation when the hexagonal pyramid, its top view could have been placed like this. Okay. So, yes, so this could have also been the situation, you get it. So, in that case you cannot use this length. The reason for that is this length on the development you cannot use, because this is not the true length. What is the true length? How will you, so for that you need to first convert this line, you make it horizontal. How we do it? So, we draw an arc and we get this line first as a horizontal line, then you draw the, basically you apply the concept of projection of lines, and corresponding to, let us say this was OA and you have OA here, or let us say this was O dash A dash and the OA. So, Using this you get A1, and after that you get capital A dash and capital O dash. So, that way you get the true length. So, this true length is to be used, not this length. So, in the earlier orientation, the edge which we had, so that was itself the true length. The reason was, so this particular edge corresponding to OD, so that was parallel to XY line. If it is not parallel to XY line, then this separate step you have to carry out. So, this has been explained in several other videos using the AutoCAD also. So, you can refer to those videos. Now, this was how the development for the hexagonal pyramid can be carried out if in fundamental form. So, if we have a cone, so for that cone you may not have you will need to know how much is the length. So, this length of the arc is not very easy to give in AutoCAD. So, it is easier to know how much angle it will span. So, the angle it will span is obtained by, so like in this case the cone is there. So, for the cone also we need to use the radial line development method. In the radial line development method, again the first principle remain the same, that is, we have to use this radius of the development as the true length, true slant length. So, true slant length for the cone is already available. Extreme length or extreme edge of the cone is itself the true length. So, that true length we have to use, and now the question is how much should be the arc length or how much should be the traverse here. So, that traverse we obtain from this formula. This formula you will have to remember. It is very simple. So, R by S into 360. So, R is the radius of the cone, S is the slant length of the cone. So, S is the slant length, R is the radius here. So, R is here, radius of the cone. So, very simple, R by S into 360, that gives us how much angle theta we have to draw, or how much will be the traverse of this arc. So, that much arc we can draw using the AutoCAD command, and finally, we can join its end with this one, and you can obtain the development. So, again as we have done in the case of cylinders, we have a number of generators here. So, generators may be left out if you do not have to transfer anything, but if you have to transfer the points from the projection to the development. So, for example, there is a hole like this. So, a hole is cut, that hole is to be transferred. How will you otherwise transfer? So, you do not have a mechanism to transfer. So, you need to transfer the points using the generators. I will demonstrate it with the help of a few examples as we move forward. Okay, in the model solution, in the next model solution we will see. So, but in the beginning, so we see how to transfer the points. So, when you have a prism. So, you can see here the prism is given, it is also cut by a section plane, that and the top portion will be removed. So, because it is a third angle method, and here we have the front view, and the portion between the section plane and the observer is the upper portion, and the development as has been explained. So, let us say this is W. So, then 5 W. So, we have carried out the development. So, one after the other you can use the mirror command, or you can use the array command also. So, these lines they can be arrayed at a specified distance, and finally, the last and the first one can be joined. So, you can apply your own methods, own shortcuts or tricks. So, a video on how it has been, how it can be drawn using AutoCAD. So, that is also available, you can look at that. So, for beginning with the work. So, here you can see this one, and this one. So, we get only 3 points. So, what we are transferring on so many edges. So, like here it represents AA and BB. So, on AA it is transferred here, and we have another AA also. So, here also it is transferred, and BB. So, here we transferred. So, similar way next we have CE and CE. So, from this we transfer it on C and E, C and E we transferred. So, this is on D only. So, this is transferred only on D. So, this way we got different points. So, these points are simply joined here in this drawing. So, the points have been joined here, and so it completes the development. It simply means that if you take this kind of a shape and then you will fold it in the form of if you cut this kind of a shape on a sheet and give it folding at different points like this, it will take finally this shape. So, that is the whole meaning. Okay, so, another thing you might notice, so here even though it has been cut here, so you have not sectioned it. The reason is we assume that it's a solid, it's not a solid, it's a hollow, or it's a solid composed of sheets. That is why, so inside material is not there. So, we omit the sectioning. So, another point you can note, if we start the development from different points, let us say starting point in this case is A, in this case is C, in this case is B, in this case is D, though the solid is the same. So, solid in all the cases, that is same, exactly same, only thing is we have shifted the starting point of the development, but the shape of development it acquires a different orientation. So, but it will lead to the same solid. So, that is the point we must understand. So, we must take care that whatever point is asked as the starting point, so it has to be adhered to. Another thing is it may be opened in clockwise direction or counterclockwise direction. You note that here we have followed AEDCA. So, AEDCA, it is the clockwise direction we have followed. So, that is what you see, step is clockwise. Second, starting point is B and we have followed the counterclockwise direction. You can see the starting point is B and we are going in the counterclockwise direction. So, counterclockwise direction we encounter B, after that B we have C. So, that is what you notice. So, B, C, D, E, A and B. So, this in this order you notice only if you move in the counterclockwise direction and starting with point B. So, this is there in all other figures. Okay. So, it gives different possibilities of the development. So, take care of what is asked from you and accordingly you must complete. And otherwise also from practical point of view, maybe you have a certain sheet metal available, let us say some. So, there is a question regarding the effective utilization of the material. So, and in sheet metals, if the sheet metal is available, you must decide what should be the starting point or different shapes you can organize, so that you can utilize the material properly. So, that may become very useful in even improving the material efficiency or material productivity. So, here we can prevent the wastage of the material by properly adjusting different options. Okay. So, because ultimately you will reach the same shape, you do not need to cut everything from the same orientation, you can cut from different orientations, that way you can save the material. I can give you simple example. So, if on one side you have this shape, on other side you can cut this shape. Okay. So, then you can save the material, but on the other hand if you insist that on a piece of paper or on a piece of sheet metal, let us say you will be cutting only this shapes, then lot of material will get wasted. So, different options of starting points, so that helps you even to improve the it offers you a possibility to improve the productivity, material productivity, particularly for sheet metals. Okay. So, now that was the practical point. So, now moving on to the next concept, that is for the development of the cone. So, we have already we have already discussed the basic development for a cone. So, we use the R by S into 360 formula for development, but in case you have let us say this profile to be transferred, in that case you definitely need the generators even for the cone, and the generators. Now, this is the section, and this you assume as if it does not exist. So, this portion, upper portion, you consider it has been cut down. For rest of the solid you have to carry out the development. How you carry out the development? You note. So, we start with 1 0 1 or O1, so this I will call as O1 O. So, O1 is transferred. You can see here the starting point I have taken as 1. So, just at 7 itself I have taken as 1. Better way will be you should transfer this whole thing, this 0 7 somewhere away from the solid, meaning at the same level, like here it was O 7, but you rename it as O1 because 1 is the starting point. Then from here you will complete the profile and or you will complete the development. Okay, so then on this you can mark. So, this marking you can do even by using the array command. So, on in another video where on AutoCAD I have demonstrated. So, you can see what steps you can take to easily put up these generators here, and for this polar array can be used. Just with one click you can create all these lines and quite accurately, and then on these lines you have these points to be transferred. So, now here you assume that on development this particular line is O1. Okay, so, O1, and so on O1 in the front view whatever point was there, that is to be transferred here. So, that is what we transfer. Next is on O2 and also O12. Note that 2 and 12 they are coincident point in front view. So, that is why corresponding point is here. So, that is transferred on O2. So, how it is transferred? So, you can see for transferring the point on O1. So, simply we had to move it and you get the point, and for after that you draw the arc here and you reach this point also. Next is the point on O2 and O12. For reaching O2 what we will do? First we will reach O1 only, and then again you draw the arc. So, this arc where it cuts the O2 on development, so that point, and O12 on developments, that point, so that point is marked. So, this way, so similar way the point will be marked on O11 and O3 also. So, that is here. Okay. So, similar way on O4 and O10. So, O10 is here and O4 is here. Okay. So, this way you get the points. So, similar way on O5 and O9. So, and O6 and O8, and finally one point on O7. So, these are the points which you see here. So, these points have been put up, so, and this can be joined together. So, maybe a curve can be fitted, or maybe you can leave it as it is, because the small straight lines taking small turns, that will also look like a curve only. And finally, so you will come to know, if you cut this shape, this particular shape on sheet metal, and you give it a turn, so that the last and the first end it meets together. So, that will give you the shape as desired, the shape which is in front view, which will look like this one. Okay. So, the frustum of the cone, it is like frustum of the cone, because portion of the upper part of the cone has been removed. Okay. So, this way you can transfer the points on the cone. Similar thing can be adopted for transferring the points on the pyramid as well. But in pyramid one special care has to be taken. So, for transferring the points which are in between, so you cannot use the arc, you will have to draw that by going parallel to the base edges. So, in the pyramids base edges will be there. So, that problem has been discussed in a separate video. Using AutoCAD you can make use of that video. Okay. So, now for the pyramid, frustum of the pyramid, again we will take up. It is constructed from sheet metal. Let us say it is a crucible constructed from sheet metal, and here the front view is here and the top view is here. So, this is visible because it is a hollow shape. So, from top when we view, so this edge will be visible, but otherwise these edges which I have marked here. So, these slant edges, many for a real solid they will not be visible, they will be hidden, they have to be shown by a dashed line, but in this case they are visible because of the hollow solid. Okay. So, if particularly if we have to develop along the base, because sometimes material may be available that way. So, along the base, development along the base may be desirable sometimes. So, base also we need and rest of the things also we need. So, for that what we do, you just need to, the base is maintained as it is. So, the base is maintained as it is. The slant faces, these are the slant faces, their true shapes are to be obtained. So, their true shapes, how they are obtained? So, we just obtain the true length here. So, you note that we have EA, that is the apparent length. So, even in the front view the EA is apparent length. So, basically you have this line and this line shown here. So, how you can bring its true length? So, you can fulcrum at this point and you can draw the arc and make it horizontal, as you do with the projections of lines. And once you do that, so let us say this is E dash, this is A dash. So, this is E and A. Now, from E dash I can obtain E1 dash as per the convention of the projections of lines. So, this is E1 dash, and from E1 dash you can draw the vertical, and from there you get the true length E. So, true length EA you can obtain by this procedure. So, that is what has been shown here. So, this has been made horizontal. So, you get the EA1 here corresponding to EA1, you get capital A, capital E. So, this is the true length. So, this true length has been exploited to show the developments, because this is symmetric everywhere. So, this can be transferred on the other side as well. So, because E, this was the point E. So, E and capital E, they have to be at the same distance from VP. So, that is how you are able to locate point E. Similar way you will be able to locate point F. Similar way, so now once you locate E and F, your whole surface, whole lateral surface now has been aligned with the base. Similar way the other surfaces, they can be completed. So, overall this way the development can be completed. It is also quite simple and it can be quite useful in some situations for material saving. Okay. So, this is another way of developing the frustums. So, otherwise the frustum can also be developed if suppose the frustum of a pyramid is there. So, it can be developed by first getting it into the proper pyramid, and then that pyramid, the development of that pyramid can be carried out. Okay. So, development of the pyramid can be carried out, and on the development of the pyramid you can transfer the points and you can get that in this form also. Okay. So, whatever form is asked you can accordingly apply. So, fine, this was about the development. Now, we go to the reverse development. Very briefly, we will just cover the concept. So, the reverse development basically means here the profile we may need to give the shape, or that profile can be obtained only on the development, then that profile is to be transferred back onto the main solid. So, it is basically for visualization how that profile which will actually show up on the development. So, that will reflect on the main solid projections. So, let us take the example problem. So, example problem, we have a hexagonal prism with the dimensions 100 mm base edge, 175 mm height. It is standing on its base on ground with the adjacent faces equally inclined to V p. A thread is wound around the prism starting from the nearest corner of the bottom base and is brought back to the nearest corner of the top base in counterclockwise direction, completing one round. Find the minimum length of the thread and show it on the elevation. Now, you see that minimum length of the thread. So, we have to completely wind it around the prism and we want minimum length. That minimum length you can obtain only through development. How? So, you can see, so it is the prism is shown here and that prism its development is carried out. So, we have to start from the bottom base. So, C bottom you have to start. So, C bottom you have to start and you have to give a complete round and finally reach C top end, which is nearest to the observer. Now, we do not know what path it has to follow. So, that path we have to show. So, ultimately first it was just for imagination that I have shown, but that was not the accurate path. The accurate path which will be minimum is from this point to this point you have to basically go on the development. So, you have to join by the straight line and those or the path followed by the straight lines, that those points they are to be transferred basically. So, you can see here. So, those points they have been transferred at respective edges, for example, C to C, so that is anyway there. So, B to this point is there on B. So, it will show up on B and then next is on A and A is also here itself. So, A I have transferred, then it is on F. So, F is here and then it is on E, E is here and then it is on D, D is here, then again it is on C. So, this way the different points have been marked and whatever is showing up on B, C, D, okay, so that will be visible. So, what was showing up on B, C, D? So, D is here. So, this is also visible. So, C is visible, D is visible and B is also visible. So, from C to B this was also visible. So, this is anyway they are visible, but they are overlapping with the other visible line and this portion that has been shown by the dashed line, which is on the rear portion. Okay. So, it is on A to F and F to E. All right. So, this is how the development or the reverse development can be utilized for solving certain problems. Okay. So, we have another problem related to reverse development and after that we shall end. So, we are given that the development of a cylinder is a rectangle of 472 mm length and then they are saying a semicircle of 472 mm diameter is perfectly inscribed in the rectangle. Because a semicircle is perfectly inscribed, so they have not given the height of the cylinder, but if they are saying that a semicircle can be perfectly inscribed, so can we get the height? A semicircle can be perfectly inscribed in the development, okay, in the development of the cylinder, which is a rectangle of length 472. So, then how it will look like? So, first we develop the first of all, so we draw the rectangle 472 and a semicircle is inscribed, that means the radius of the semicircle will be half of, or radius will be 472 by 2, or the diameter of this thing is. So, if radius is there this, then this is also the radius. So, that is the radius, and radius is equal to 472 by 2. So, from that we get the height. Earlier we were not knowing how much is the height of the rectangle. So, first we started with this yellow colored semicircle, and around that we fitted the thing, or we can easily make out that the height of the rectangle which will be there. So, in which it will be inscribed, the semicircle is inscribed, that of course will be equal to the radius. So, now we have to show it on the main solid. So, that is very simple, simply we have to transfer the points like this on the main cylinder. You can easily see that from 1, so 1 is here, so and 1 is here, and this is on 2. So, 2 is 2 and 12 are here. So, on that, so we have shown. So, this way then on 3, so we have, so 3 and 12, so different points we have transferred. So, exactly on the rear end, so one path is there in the front end, one path is there on the rear end, but front end will show up, rear end that will anyway will not be shown, because the precedence will be given to the visible lines. So, this is how the reverse development, this is the another example of the reverse development. It explains how the reverse development problems they can be solved. So, basically you will have the profile on the development, that profile is to be transferred back to the development. In the case of direct development problems, we define the profile maybe by a cut or maybe by some other thing, section plane. So, we define that on the development and then we transfer it to the development. We show it on the front view and top view, and then we transfer it on the development, that is the real development or the direct development. Reverse development problems, so we just give the nomenclature as reverse development. So, in that we have to create the development first, and then we have to transfer that profile onto the main projections. So, basically development means the surfaces of the solid, so they are to be covered. So, we may think that it is to be covered by a cloth, or maybe through a sheet metal we are going to construct. So, this is a typical example we have here. So, it is a hollow shape, we have given the shape with the help of a cardboard. So, it is a square pyramid as such, but the development, so what is the development? So, the true shape of the surfaces, so that is captured and that is joined one after the other. For example, in this case, if I develop it from this edge, from starting from this edge, what I will get? I will get a slant surface like this. After that again another slant surface, triangular slant surface, again triangular slant surface, again triangular slant surface, but all with the center here. So, when we open this you will see, so this slant surface, and you see next slant surface is opening, then you see next slant surface is opening, then finally the fourth slant surface is opening. So, this way you may get the development. So, through the development what you can do is, if this shape is cut on let us say a sheet, then that sheet can be given the shape of the solid, and or it can just envelop the solid. So, if let us say we have to cover it with the piece of polythene, we have to cover it with the piece of some let us say acrylic sheet, or we have to put simply cloth. So, then so this particular concept of development, it is of help. So, it can be used even to manufacture it through the sheet metal, the solids when they are manufactured through sheet metal or different other types of sheets. So, this concept of development is very handy for that, it is fundamental to that. So, this is all. So, hope you got the idea and you will be able to tackle the situations. You will need to use the other set of videos also, and this should help you to deal with the challenges involved in development perfectly. So, thank you so much.